Hello.
Hi, Jalaj.
Okay. So we'll start with the second part of the else condition. Okay. So if I just open the Visual Studio. Okay. So this is the else part. I'm just going to uncomment this. Before, like yesterday, we have seen the if part, that how we can load the day one data, how to assign surrogate keys, how to assign load timestamp, and how to assign active indicator. Those all things we have seen till now. And today we are going to see the else part. Like what if we load the same data on, like if we get the next CDC data on day two. Okay, so this is my current data. Okay, this is my current data, and I'm just going to copy it actually on different sheet. Okay, so let's say if I come at the end, let's say what we do here, we add few new records here. Okay, maybe let's take these IDs and paste it here, and these are my new records. Okay, these are my new records. Let's say I get 4 new records in my data source. Okay, and new record will obviously have some different IDs, so I'm just going to assign some different IDs which are clearly identified if I run the code. New listing IDs, just to make sure that we are having our new records here. So I have added 4 new records in my source file, and let's say I delete this record called let's say this last 2 records I will delete. Okay, I'm just going to actually, okay, just copy paste and delete. 2 records I have deleted, 4 records I have added, and let's modify a few records. So let's like it is like $200, so I'm going to make it $400, and this record I'm going to make it uh, again $400, same thing. Okay, so 2 records I have updated. So now we have example of updates. Now we have example of examples of this thing also. Delete and insert. Insert means new records. So let's see how we are going to capture all these changes in our code. Okay. So if I come back to my code, first of all, my code will be running on else condition. Why? Because if I run it now, so if, we know that we have loaded 1499 records in our Redshift table, and if I execute this code right now, okay, if I execute this code now, I am going to get length of previous data frame take equals to more than 1. Eventually it's going to be 1499, but as I'm saying take 1, that means it's going to be 1. It's not going to be equals to 0, and that is the reason we are going to come inside this path. Okay, previous found in found in previous folder, and we will run scd. Okay, so this section will be taking now. So now we will apply a few joins in here. Okay, so actually if I talk about scds on databases, we might have some inbuilt functions, we might have some options, and we might have the foreign key changes detection, all those things we might have there. But as this S3 is not a database, it just it just simple data source for the file. So I do not have any such option, so I have to check everything. So first of all, I am going to find new records which are added newly in the source. Okay. So to find the new records, what I am doing here, first of all, I am taking my source data frame. Okay, the source data frame that we are actually having in the input folder, that we will take here, and then I'm going to say dot join. Okay, I'm going to join my data source data frame with previous data frame. Remember, I have told you the source data frame is going to be left table. Like anything outside the join is actually left table, or inside is right table. Or if you see it very simple, like table name on the left hand side of join is left table, or right hand side is treated as a right table. Okay, so I am joining these two tables. I am joining source data frame with previous data frame. I am joining these two tables on listing ID because we know that both the tables has listing ID column in the tables, so we can join based on the listing IDs. But here, sorry. But if you see here, my join type is actually left empty. Okay, my data join type is actually left empty. So you guys know left empty joins?
I think it will come only the non-matching record from the table B.
Actually, yes. Table A, like I mean, see, it's something like it. Let's just give you one example also, then it will be more clear. So let's say we have some. This is my left table, and I have some primary IDs such as 1, 2, 3, 4, 5, 6. Okay, let's say we have these many IDs here. And then let's say we have a right table. And let's say in right table we have 1, 3, 4, and let's say we have 1, 4, 3, 4. Let's say we have these three IDs. So if I do left empty on this table, okay, on left table, if this is my left table, this is my right table, if I do left empty, I will get an output. I will get 2, I will get 5 and 6. That means whatever the IDs that are matching with the right table will not appear in the output. That means basically you can say 1 and 1 will be deducted. 2 is not there in the right table. That's why I'm going to get 2 in the output. 3 and 3 will be removed, and 4 and 4 will be cancelled. You can simply take it like this. So if I come back to my code, let me actually delete the sheet. So if I come back to my code, same thing I'm doing here. So in my source TF, now I have 4 new IDs which I have created right now also. Okay, and I'm going to compare this with previous data frame. Obviously, those 4 IDs are not available in the previous data frame. Like rest all 1499 IDs are available in the previous data frame. So with this simple statement, I will be able to get what are the new IDs that I have in my left table. Okay, this will give me new records that I have entered in my data frame. So I am going to create a new data frame that is going to be called new underscore df. This new underscore df is going to have the new records that we have added inside the source. Okay, and then on the same new record, on the new records, the same way we have done the surrogate key logic on our first part, same way we will do it here. Okay, we will generate monotonically increasing ID. We will create a window function. On that window function, I'm going to apply row number and windows I'm going to apply a row number over my Windows pack. This is going to give me surrogate key. But here one thing is we need to consider. This row number is going to be starting from 1. Okay, but we already have 4099 records in our Redshift table that we uploaded yesterday, and obviously we don't want to start the sequence from again from 1. So what we have to do, we have to collect the maximum ID from our Redshift table, like what is the maximum ID that we have, and we have to add that in this row number. So that's what I'm doing here from the previous data frame. Okay, from the previous data frame that I'm reading from my Redshift table, I'm going to look into surrogate keys max value. I'm going to collect that. Okay, going to look for surrogate keys max value, going to collect that, and this max key value is going to be 1499. And if I add 1499 in 1, I'm going to get 1500. So this is how I'm going to make, or I'm going to make sure that I'm getting a proper sequence in my surrogate key column. Okay. Then as usual, I'm dropping my index column, applying the load date, applying the active indicator, because obviously new records are going to be active only. So yeah, this is the first part, that identifying the new records and massaging them for surrogate keys and load time and active indicator. So yes, if you have any questions in this part of code, please let me know.
Line number 117, this collect thing, can you explain again?
See, this, if you just don't say collect and if you just say aggregate, this function is actually going to give you a data frame, but we cannot add and this is integer. Okay, this line is going to give you an integer. Okay, and this line is going to give you a data frame, but we don't want a data frame. We want a proper output into integer format. That's why I say collect index 0, sorry, row number 0 and column 0. So basically, if I come here, something like this you are going to get surrogate. I can show that to you on surrogate key. It will be 1499. This data frame you will get it. Okay, you will get some data frame like this. Okay, a data frame sort of like this we will get, where we will have one column called surrogate key, and it will have the value for 1499. But when I say collect 00, that means 0th row, 0 index row and 0 index column, I will be collecting this value in an integer variable, and that variable is actually max key. This will become something like this. And if I don't say collect, my max key will be a data frame. If I say collect, my max key will be a integer 1499. So basically collect is here is actually helping you to pick the exact value in a simpler data format. Okay, without collect, it's going to give you a data frame.
Jalal, can you show me the monotonically increasing ID where we used in the previous once again?
It is here, like to assign the surrogate keys.
Okay. Okay. So usually in the data processing steps, so this max step will be aggregation, right? Aggregation.
Yes, yes, it's aggregation. I'm using AGG in aggregation.
Mhm. Got it. And timestamp is the final one.
Yeah, timestamp is like the latest timestamp that whatever you will have at that particular moment. It's not a
Mhm.
timestamp, it's simply date.
Right, right. Yeah. Whatever the changes happening in the data set, it will records on particular day.
Yes, 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 yes. And see one thing, obviously we can have variations in the your project. I mean, this is just example things I'm showing you that how real-time
Mhm.
project works. But obviously you can have a lot of variation. It might not exactly, it might not even match 1% with this, but your all the knowledge, concept, skills are going to be same. Might be approach might be different.
Right. So most of the times in real time at workplace, the error logs mostly will use in my function notebook or the glue pathway. I mean glue or whatever we Spark
See,
engine.
no, no. This my function is just a one more code. Okay, yeah,
Right.
just this is just a one more code. So in real time, actually, it is advised that something if you are reading using repeatedly, like if I talk about the function this
Right.
copy to redshift, this we will be using in the same format. We will be using it many times with let's say 100 of codes. So why to copy paste in 100 of codes? Like just create
Got
one like functions. You might not call it. You might not call it my function. You might call it something else also. Obviously,
Oh,
my function is very simple.
it's a lambda function, right? That is a lambda. We are calling for lambda trigger from
No,
my
no,
function.
no, no, no. There's no lambda. There's no lambda. It's just one more code. So in
Not here.
programming, you can
In my
do.
functions, we use the boto in the beginning.
So see, Boto I can use here also.
Okay.
Boto is not
Oh,
restricting to be
it's
utilized
not.
only with lambda
My
functions.
function is not going through lambda.
No, no, no. It is just a one more code. It's just a one more file of code.
Oh, okay. Mm-hmm. So when you're triggering using the both scripts to trigger, right? Running the scripts.
No, what happens? If you just see here, if I come in job details, I am defining the location of that script. This is my functions. I'm defining the location of this script. This
Okay.
basically means in easy terms that I am going to provide you some script in this script location. Okay, I'm going to provide some script here, but
Okay.
please also consider the script written in the my functions location.
Okay.
Okay, and when
So
it considers that location, it will find this copy to redshifts logic.
is there any my function file name in this PySpark shell job in this script?
See, what again focus on this. See, I have just uploaded my functions on S3 and I'm
Okay.
passing its location. It is available in this bucket.
Okay.
And I'm simply saying we have to consider both the codes, script code also and this code also. It is just that I'm not going to copy paste the code again in my main script. I'm abstracting my code into a different location.
Okay. So the script in the console and this my function file both are same.
No, these are not same, but these two are different files creating one single job known as project hands-ons.
Mm-hmm.
So basically you can say project hands-ons has two scripts, one your normal script, one your my function script.
So in what circumstances it will use the my function script? If
Whenever
it is
you are calling the some function from the my function, so whenever you're saying copy to the redshift, it is I'm saying it is defined inside the my function. It is not defined here.
okay.
Yeah, I'm saying
Mm.
I'm clearly saying that it is defined inside the my functions. you will not find the definition of my functions, or sorry, you will not find the definition of copy to Redshift here in this code.
Okay. Got it. So generally, for every step, we have to use the error logs in the script, right? Because without error logs, they won't allow for the production.
Error logs means?
Error logs, like if it is running, so I mean, else except like
try catch.
Try, yeah, like that.
Yeah, so actually, see, I'm using the try examples I have given you in the my functions. I'm not coded that into that side. You can actually simply just use try, and then just have a. Here is actually not try catch. It's actually try exception, try except block. Just copy paste these things.
For each definition, we have to make it like that. Okay.
Yeah, I mean, ideally yes, in real time, yes. Even if you see, I'm having most places.
Right. And logging information we have to include in the end, right? For that, suppose if the script someone is running in their system, so who is running, who is using the script, to know that we have to use the logger information. Do you have any code for that logger information?
No, it's not like that. I mean, see, if like suppose this is the account, our main account, and if 10 users are using this, those all 10 can actually modify this script at a single time, and they can mess up each other's codes. So this is something you have to communicate within the team, and you have to let them know that I'm working on this particular job. Please stay away from this.
Okay.
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 So this is the code to identify the new records. Actually, new records and deleted records are easy. So in new records, I am keeping my source data frame as a left table. That means if something new I have in my source data frame, that will remain and get traced in the new data frame. That will be actually coming in the new data frame. For example, for right now, I have modified 4 records. If I upload that file and if I run my code, I will be getting 4 new records inside new data frame. Okay. And same way, I am actually getting my deleted data frame. Okay, I am getting my deleted data frame. That means records which are present in the Redshift right now, Redshift is actually previous data frame, but not present in source data frame. That means if some records are here but not here, those only will remain, and that means source does not have those records now, and those are deleted. Again, we are using the left anti. See, left anti, joining column, and tables also are same, just I have swapped the tables. Okay, for new records, you will be having source data frame in the left hand side. For the deleted records, you will have the previous data frame in the left hand side, which is making sense because this time we are looking what are the records which are in the Redshift but not in the source. Okay, which are in the Redshift but not in the source. So to do that, we will say left anti on previous data frame. Is it making sense? This line number 133.
Yeah, got it.
So yeah, so now these records are actually deleted records. So I have to, apply active indicator as N, not Y. I'm going to apply the timestamp when this record got modified. Okay, I'm just going to add the timestamp here and going to show the data to on console just for the showing purpose. This is the logic to get the deleted records. Okay. Now these records we have actually got in the. Now these records actually we have got in the deleted DF. That means a new DF that we have created. One more DF I will say we have created as known as deleted DF, and this will have 2 records. Okay, but those 2 records are still actually present in the previous data frame with the Y entry, and we need to delete those from the previous data frame. So I will just say previous data frame equals to previous data frame. That means I am looking to modify my previous data frame, and I am saying delete these 2 records using left entry. That means whatever the records I have in the deleted data frame, those will be actually removed from previous data frame. Okay, that means the 2 records which I have deleted from my source table will be there. First they will be cached in this logic. First they will be cached in this logic and they will appear in this deleted data frame. Then I have to clear or delete those 2 records from the original previous data frame. Then I will just again use left entry to delete those 2 records from previous data frame using deleted DF. So this has 1499 records. This has 2 records. After this execution, I will get 1497 records. Is it clear this part? Because it's I know this is a bit confusing. This is a bit confusing.
Yes, got it. Clear.
Okay, Varsha.
Yes, Jalaj, got it.
Okay. Don't worry. I mean, we will definitely be executing this also. Now this is actually a process for check of updation of the records. Okay, this is the process of updation, checking for the updation of the records. So let's be patient here. First of all, from my source data frame, I am renaming my columns. Okay, let me just press Alt Z. I am renaming my columns from my source data frame. I'm saying price. I'm calling it source price. I'm saying NBH food, NB hood full. I'm calling it source. Like after before every column, I've appended a source underscore on that. Okay, why we are doing this? So if I open one more Excel file. So let's say we have 2 data frames in our PySpark. We have ID and name. Okay, this is my data frame 1, and then this is my this is like you can say first data frame, and then let's say I have a same data frame here, ID and name. Okay, let's say I have 2 data frames like this, and if I join this data frame based on ID, I will get ID because I know PySpark will intelligently identify that we are joining this 2 data frame based on ID. So it will remove one ID because it knows that those 2 IDs are actually same, nothing different there. Okay, it will remove one ID, we will get ID, but we will get name twice. We will get name and we will get name like this. This is going to be my resultant data frame. Then at the time of selecting something, okay, when I say select name, I will get the error that name is ambiguous. It could be name or name. Okay, that means name is appearing up twice in my data frames. Now, and this is only in the case of inner join. Okay, this is only in the case of inner join. Okay, now if you see here, we are going to apply inner join. And the column names in both of my like source data frame and the previous data frame, the column names are actually same. So I am simply converting my column name so there's no confusion in future. Okay, I am simply calling my price to source price. I'm clearly indicating these are my source column names. Okay. Now, this is fun thing that we are changing column names. We are preparing our data frame for our inner join. Okay, and then we have now we need to identify which records got updated. Okay, and before finding out which records got updated, we need to find out which records might be updated. Okay. So obviously the records which got deleted are not the ones updated. Obviously the records which are new are not updated records. So updated records means the record which was present in the Redshift and it has appeared again in the source. Only those records can be your updated records. Okay, those records can be, I'm saying can be, I'm not saying surely they are updated records. Those records can be the updated records. Okay, so this is the reason why I am saying on previous data frame, join it with the source data frame, and this time using listing ID, but my join is inner. That means all the records, all the listing IDs which are present in both the data frames will appear here in this final result data frame, that is update check. Okay, this update check will have all the records which could be updated. Okay, and from the update check, I am picking listing ID, source price, source name and beautiful, source new price, surrogate key, load time, and active indicator. Okay, if you see, I'm picking source columns. I'm not picking Redshift column because we want to take the latest value of the column. That means the latest value that we have inside the source, we want to take those values. That's why I'm taking the source column. I'm not taking the price and be at full. I'm taking source, price, and be at full. Okay. Okay, and again simply I'm converting my source price to price and like that, like renaming the column back to original form. Okay, this is how I'm creating my data frame called update check. Let me repeat it again. As we were going to do inner join, we renamed our columns for the safety purpose. We performed an inner join to get the columns, get the rows which could be updated, not surely updated, but which could be updated. Could be means the columns which are present in both the data frames, that means Redshift also and source also, those could be updated. That's why we have performed inner join and got those columns here in the update check. Selected the required columns because this will give you double columns and we only need single columns for source, price, source, and beautiful. And we pick the source columns because source has the latest values, not the Redshift has the latest values. Source has the latest values. Okay, this is the reason why we picked the source columns here, and then I simply modified my column names back to normal columns. Okay, I simply put it my column back to normal columns. And then, okay, first of all, I will wait here if you have any questions here.
No question.
Is it same with you, Rama?
It looks good, but the thing is, small question. Why we are renaming and backing to normal name? I mean, previous name. I did not get the point. Maybe I'm not concentrating. So
no issues. Let me resume the cluster so when we will actually execute this. Okay. See, I just came here. If you see, right now, both my source table and my Redshift table has the same column names. Okay. If I apply join on ID column, I will get something like this ID, but this name will be picked twice by the inner join. Okay. In the inner join, this name will be picked twice. Okay. So if I try to do some select statement on this name, I will have some confusion because like it will fail with the error that name is ambiguous, like it's appeared twice in your data frame. So at that point of time, my query will fail. That's why I'm clearly renaming this to source name. Okay, now after inner join, I will get something like this. I will get source underscore name, and I will get name. And as my source table has the latest records. Okay, as
Right.
modification happened in the source table, I am going to pick these two. I am going to leave name because this is a having previous values. And then I'm simply renaming my, like I will pick this first here, and I'm going to rename it to normal form.
So renaming we are doing only in source, not in the existed Redshift, right?
No. Only once, like if you rename it on Redshift or if you rename it on source, any one you have to rename to avoid the confusion after the inner join. If you're performing inner join, this will actually be confusing.
Okay.
So to avoid this case, we want to rename our columns.
Okay, here we are not using like SQL join statements like alias a dot column name and b
Yes,
dot column name like that.
yes. Actually, that one actually we could have done. That actually we can do. I have already told you also that how we can do that. If I open one
It's
folder.
a straightforward. This is simply without making complex. Okay.
Yeah, I mean, it's actually choice. It's your choice. It might be something, might be a simpler for you. It's like that only. If I just open that code on, okay, not here. If you see in this join condition, you can say something like this: select name from countries df and alias it as country name. Okay, and then if same like from select name from regions tf and alias it as region name. So this also you can do. You can like after like see I'm here also I'm doing join. It's an inner join only, and I'm saying select countries like name. If you're selecting from country's name, call it country name. If you're selecting from region data frame, call it region's name.
Right. Okay.
So both actually both approaches are actually correct, but just your convenience, which is preferred by you. Okay, so we have got our update check data frame. That means now we know which columns could be updated. Now what we will do, we will take update check as a left table, previous data frame as a right table, and on these two columns we will join. Okay, on these two columns we will join, and then we will use left anti. That means if these records are not matching, okay, if these records are not matching, then only we will get output in our updated df. That is my result data frame. Okay, this means all the records which are not updated obviously going to be ignored by this left anti join, and all the records which are actually modified there, the price and nbhoodful join will not work, and they will be captured inside updated df. For our use case, we have two such records. Okay, if you see here, I need to open my data. Just a second. This is my table. So see what I'm trying to say here. All these like $125 and Manhattan East Village, this record will be matching with the direct shift because this record is also present in the direct shift. This will be ignored in the left anti. Same way, all the records will be ignored. But here, like in Redshift, we will have $125, and here we have $400, and this record will fail to match, and this we will get inside the updated df data frame. This is how we will get our updated data frame results. Is it clear?
Yes.
Okay. So see, now we have got updated data frame. Okay. And on this data frame also, like we need to assign new surrogate keys because we maintain the history. Okay, because we maintain the history, we do not delete, we do not delete anything. We maintain the history. Okay, just for that reason, we need to update this surrogate key, and I am going to say surrogate key. I am same logic, automatically increasing ID, window function on IDX, but this time I am saying f dot row number. Okay, and then I am saying max key. This max key I have got, it is the same max key that I got on my new data frame. Okay, this is my that same max key. Okay, now once I get this max, so basically it is like on my previous data frame odd count of 1499. Then on new data frame we will have 4 for our example. So it is like 1503, and now I have updated df. I want to assign surrogate keys here, so it should be addition of this thing 1503 plus something. Same thing actually I am doing here. I am first, this will give me 1. Okay, this will give me 1. This max key will give me 1499, and this new df dot count is going to give me, okay, this new df dot count is going to give me 4 because we will have 4 new records in our data frame. So we will get 1504 as surrogate key for our updated data frame. Okay, now you might have a question that we could have got the max key. We could have got the max key with the same syntax like the new data frame dot count. Yes, we could do that, but I just wanted to show you the aggregate functions examples also. So that's why I have used collect. Okay, so maybe in future if you want to collect some particular columns value in some variable, you can use it with this syntax. Just say aggregate function, maybe max, minimum, average, sum, anything you can do, and then collect that for your use case. For this use case, we could have simply said previous df dot count. Okay, so do not get confused here. Both syntaxes are actually going to fulfill the same requirement, but sometimes in different use cases we could have used those differently. Okay, then the same approaches, I'm dropping my IDX because it is not required, just increasing numbers. I will apply active indicator as Y because updated DF means the new records are going to be updated one. Those should be Y, and the previous records which we have to modify to N also. And we have applied the timestamp here. Okay. Okay, and this select is just for making the correct sequence. So at the end we are going to do union all. So to perform union we need to have all the columns in the correct sequence. Just to make it in the correct sequence, I have applied this select statement here. So we are first of all we are getting the data frame where records could be updated in the update check. Then we are using left hand on the price and beautiful columns to find the records which are actually updated. Then we are applying increasing ID to perform the surrogate key. But in surrogate key, we are not starting from 1. We are starting from 1504. To do that, I'm saying new data frames. I'm taking new data frames count and the count of my previous data frame. Then I'm simply keeping the active indicator Y and applying load timestamp here and making the sequence correct with the select statement. So yes, if you have any questions here.
No question.
Okay. Rama, is it same for you?
Yeah, Jalas, if you see on line 159, when we are using the creating the updated DF, the column will what name the column will be printed? I mean loaded.
Surrogate key.
Surrogate key. Okay. Usually, what is the purpose of this surrogate key?
I mean, seriously, sometimes I'm also wondering why we are assigning this, but it's just a surrogate key. We just create a sequential numbers to, identify the records individually.
Like a SQL hash key?
Kind of, yeah, kind of.
Okay. Okay, Jalas. Thank you.
Yeah. So then if I move ahead, so see, we have till now we have identified updated records, deleted records, and yeah, updated, deleted, and new records we have find it out. Okay. Now let's see records which are not updated. Okay. Okay. No, it's actually the records. See, we have found the updated records. We have marked its activity indicator as Y, but we also had to find the records, the previous record for this one. Okay, that means I have to go in previous data frame. Okay, I have to go in the previous data frame because previous data frame will also have active indicator as Y for these two records. Okay, previous data frame is not modified yet. We just got updated data frame, but we still need to modify the previous data frame. Okay. So same way, I'm again creating I'm again modifying my column names. Okay, for the same purpose because I'm going to apply inner join. You could also do alias option. You can also take the alias option. Okay. I'm simply renaming my updated data frame and calling updated df, and this means these are the records that I have to mark as n in my previous data frame. Then I'm joining previous data frame with updated data frame in the inner type. Okay, and selecting the required columns. Okay, selecting the required columns, and then I'm going to mark those entries as n. This means only two entries are here. Okay, only two entries will be there in the updated df n because it is equals to updated df. I am going to take two records here. I am going to apply inner join here, and I'm going to get two entries in the previous data frame, and those two entries I'm going to mark as n because now those two records are not active. Okay, now those two records are not active. I am simply going to take those two records and I am going to do okay. First of all, let me know if you have any questions in this before moving ahead. Just let me know if you have any questions in this.
No.
Okay. Okay. Then the next and final step is simply what we are doing. See, from the updated check, we have identified the records which are actually updated, but in this step we are identifying the records which are not updated. Okay, so with this we will have all the records set with us: new data frame, deleted data frame, updated data frame, and non-updated data frame. Okay, we will have all these records, and we will also have previous data frame which has only two entries for non-updated records. Okay, at the end it's very obvious that I am going to union all these data frame. Okay, I'm just going to do a union on all these data frame, and this is going to be my final data frame. Final data frame, I am going to put it inside Redshift. The process is going to be same. Okay, the process is going to be same. I will have an output, and I'm going to convert that into a dynamic frame. I'm going to write my dynamic frame on my output location, and then I'm going to call my Redshift function. Okay, then I'm going to call my Redshift function. So actually, let's take this job now and update the code here. Now my Redshift should be available. Yes, it's available. I have modified my code here. Before executing this code, we need to do one thing. We need to update our data set. So my location of input is actually data engineer course Airbnb. Here I will remove this file. Okay, I am just going to upload this one. No need of these things. No need of this column. And save this. And I'm going to upload that file. Add files and home. Let's take this file. It's Excel access, not no. Wait. I need to open this file and file save as this PC. Maybe downloads is fine. It should not be Excel workbook. It should be CSV UTF-8. Save to this PC. Going to cancel this one. Yes. Upload. Add files. Home. Yeah, this one we need to take the CSV one. Okay. Don't take Excel files. Upload this. Yeah, it's done. Now if I come here and this is updated, I can click on run. I will come inside the runs part. I am going to open my CloudWatch logs. Let's see what we get in the CloudWatch logs. You can see I am saying found data folder in previous folder. Okay, we are running SCD now, and then it is we are going to get the results of SCD now. If I open this, get this pasted on my notepad. These are the 4 records that we added newly, and this is coming inside the added records. If I simply come down, I am showing deleted records. Copy this. This is my deleted records. 2 records I have modified. Then my updated data frame. This also has 2 records correctly identified. And this is my not updated data frame, which will obviously have more records because most of the records not updated. Then we will just simply come down. This is my final count 1505. Okay. 1499 previous entries, 4 new entries, 2 updated entries. Okay, this is what's going to be my final output, and then this is actually my final output continuing. Okay, and then I'm modifying my Redshift table. Okay, data load for Redshift table is actually finished. Okay, it's also making a new entry in the DynamoDB. I'm going to explain what kind of entry we are making in the DynamoDB and how we are doing it. So yes, if you have any questions in the execution side, and we can also come on Redshift, on query editor, connect to database, and let's say select star from here. And I can export this into CSV. This is how my final result looks like. Okay, I can do it this thing, data filter, and if I just get the n entries, you will see I have 4 n entries. 2 records are actually deleted. Okay, 2 records are actually deleted, and 2 records have been modified. Okay, 2 records we have deleted, and that's why they have an entry, and 2 records have been modified, so they will have 2 entries. Okay, so you can verify your output, like you can perform this on your side, and you can verify the output also. And if it I missed to actually it is this thing. If I do filter, I can get it by surrogate keys. 1503, sorry, 4 and 5 are my updated records. That means these are the 2 records which have Y entry, and they will also have the N entry. That means listing ID 12, these 2 listing IDs. Just get that into Notepad. Okay, I'm going to remove the filter, reapply the filter, reapply the filter. I'm going to apply it on listing IDs, and I need this one. Okay, you can see we have 2 entries for this. This is $200 is the previous entry with the active indicator as N, and then we have $400 entry as active indicator Y. Same thing will be there for second record. Select this. Yeah, previous entry is $240. Now it's $400. So yes, if you have any questions, doubts, issues here.
Just like we are writing this data frame to Redshift, the same way we can write this data frame to DynamoDB also.
No, it's a different way.
Okay.
See, one thing, guys, I mean, this might be clear to you, but one thing, please try to set it up on your side, because setting up this code will also take some effort. Okay, it will need some Redshift table creation, it will need Redshift cluster creation, it will need DynamoDB table creation, node code creation. You might look to modify this code as per your requirement. You might look to play with this code then actually you will get the more knowledge from this code.
Okay, Jalaj.
Jalaj, could you please share this all source files, S3, whatever you use the Excel sheets,
Only one
CSV
example I
files?
have used here in this code. I am just going to share it with you, that we can
And
actually modify as per your convenience.
yeah, previously, whatever you use the Excel sheet and spreadsheets, that those also we'd like to have it because when we are trying using the same code and that same file will be helpful instead of our
Yeah, no, sure, no, sure, sure. See, air price is the file for this particular code. Countries.csv and regions.csv is the examples code that I have showed you in the notebook side.
okay, okay. Also this updated scripts.
Scripts I have already shared, but yeah.
Day back yesterday you shared that one, but after that you changed some lines.
No, 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 I have not changed actually. That is not going to make any big difference also. It's just the same script. Anyhow, I have not changed any. I mean, I don't remember that if I changed something. No, I haven't changed anything. Might be just spelling things like running spelling was wrong in the print command. That's all I have changed here.
So what next, just topics?
It's like we still have to finish this code. Okay, like right now we have just done the, you can say SED we have done, but still, sending the emails and updating DynamoDB, those things we still have to cover. So that we will do tomorrow.
Okay.
Then I will look to plan EMR.
Okay. Probably next week we are closing, right?
Yeah, Monday or Tuesday we will finish this.
Okay.
Okay then, yeah, we'll meet tomorrow.
Thank you.
Bye.
Thank you, Jalas. Yeah, bye-bye.